Hi, this is Sudeep Panchanda from Quite Easily Done. This video is a part of the series Know Your Boards. The series is aimed towards better understanding of the boards that we're using in our projects. This information will not only help us to be able to create these boards at home, but will also help us customize the boards to our own needs and improvise the designs. The board that we will be talking of today is an LDR, dependent light intensity detector. So this board has an LDR, a light dependent resistor, and it has two outputs for us. One detects if the light is below the given threshold or is above the threshold. So it's a low light intensity detector and a high light intensity detector. The light intensity threshold is set through the potentiometer that we have over here. It has an input supply of 5 volts and the two outputs that we had talked of. So let's have a look at the board in action for better understanding. So here we have the light intensity detector connected to the power supply to the inputs over here. And when I switch on the power supply, I get the green light, which shows that the light intensity is above the threshold right now, obviously because I have a good amount of lighting right now over here. When I cover the sensor, the red LED would glow, which shows that the light intensity is now below the threshold. So above the threshold, below the threshold, the one output over here is the high light intensity and the other one is the low light intensity. Let's have a close look on that also. So we have two outputs that we get, the high light intensity and the low light intensity. The potentiometer over here can be used to change the threshold if you wanted to use it some other ways.
So here we're looking at the circuit diagram for the light detector. The light detector mainly works around the photoresistor, and for the photoresistor is the resistor whose resistance would change depending on the intensity of light that is coming on it. The details can be found in the Know Your Components resistors video. And then we are using an op-amp, an operational amplifier over here as a comparator to look at the voltage difference between the pin 3 and the pin 2 of the operational amplifier. Again, the details would be available in the Know Your Component section. In this video, we would be looking at how these individual components have been put together to create a light detector. So like always, we have is the input terminal, where the plus 5 volts is marked as VCC and the ground is marked as GND. So if we look at the left of the circuit over here, we see that we have is two 7.5 kilo ohm resistance being used as a potential divider between VCC and ground. Because the resistance values is the same, the resistance at this value at the junction over here would always be a 2.5 volts, which is what is being fed at the pin 3, which is the non-inverting terminal of the operational amplifier. Now this value at pin 3 is constant always, irrespective of light intensity, and we want the intensity we would want the voltage at the pin 2 to be dependent on the light intensity, so that the comparator can compare if enough light intensity is being detected by the photoresistor over here or not. So we know that the photoresistor, the resistance values reduces with the higher intensity of the light. So when the light intensity increases, the resistance reduces. Now when that happens, when with the higher intensity of light, the resistance reducing, the voltage over here at the pin 2 would increase. So when there is sufficient amount of light over here, such that the voltage at the pin 2 of the comparator would be greater than 2.5 volts, the comparator would give us a logic low. If the light intensity would have been lesser than the threshold, we would have voltage lesser than 2.5 volts at the terminal 2, which would give us a logic high at pin 1. So basically, the output at the pin 1 of our IC LM358 gives us a logic 1 when the light is low, and that is what we are giving as an output to the low light detection. LM358 has two operational amplifiers in it. We're using the second operational amplifier in a reverse configuration, in which what we were giving up as an input to the non-inverting terminal of the first operational amplifier, we give that as the input to the inverting terminal of the second operational amplifier. So basically, if the output of the first operational amplifier was a logic high, the output of the second operational amplifier would be a logic low, because they are doing a comparison of the reverse. So that is why the pin 7 of the operational amplifier IC gives us a high light detection, and the pin 1 was giving us the low light detection.
Thank you very much for watching the video. Please let us know of your comments and questions in the comment section below. We would revert back to you as early as possible. Thank you very much.